it's really hard to succeed in the class, I guess, is what some people were saying.
Yes.
Because there's nothing, that's the only thing that's being graded, so.
Makes sense. Yep.
Yeah. All right, so hold on, I got
So
that.
is the quiz like a problem from the homework or
Oh,
like
okay,
the
yeah,
homework?
yeah,
Or
the quiz is just a random problem from the homework.
okay.
But you can do the homework the night before, and he has a full answer key, so.
That's helpful. All right.
Yep.
Yeah.
All right, let me find your email.
Let me know if you need the email, or you can also reply to the booking email. That's easier.
Yeah, hold on. There we go. Let me know if that goes through.
All right, there it is. Oh, you sent over something from your drive. There it is. It did pop in. Okay, let me look this through. All right, yeah, let's I guess go through these one by one, although we might not be able to do them all. Is this a duplicate? No, I guess it's just another page. Okay, yeah, let's go through these quickly as we can. Try to give you some helpful.
All right, hold on, let me find my pencil. All right, I'm good.
All right, so the instructions here, they're a little bit odd, but it says solve each of the following inequalities, graph each as a system, and shade highlight the function where the y value satisfies the inequality. State your solution and set builder notation, interval notation, determine if x equals 7 is a solution. I guess that changes as well for each one. So there's sort of I guess there's a couple of oddities here. The first, I guess, is you're supposed to treat this as y equals absolute value x plus 8 minus 16. Okay.
Mhm.
Absolute values have sort of this V shape, either V down or V up. The standard form, which I will write because it will help here, is absolute value x minus h plus k. The vertex is the main thing you need to take away from that. That's h and k. So notice h is the opposite sign of what's in here in the absolute value, and k is exactly the sign that's in there.
Right.
So what would the vertex be for this one?
Like, you mean the dot in the middle?
Yes. What is the vertex here for this one? Yes, that dot.
How do you, or I mean,
Okay, so let me give it to you the first one. It's -8, -16. So the h value comes from inside the absolute value.
how does it become negative though? It's okay.
We can talk about why that is, or we can accept that it is always negative of what's inside there.
Okay.
And I'm happy to do either. I'm just letting you know you may or may not like how much time or the explanation on that. The 16 or the k value is always that number on the right, or whatever's outside the absolute value.
All right.
Okay, now that's the dot. Okay, so that, -8, -16, I'll call right there. Okay, now based on what I'm seeing here, like, you don't have to you don't have to be very accurate, which is a little bit bothersome here because you don't know whether this thing crosses there or crosses over here.
Yeah.
And I'm not sure why this is the way it is, but we'll just, some sort of a V. Actually, that's not even very good. Some sort of a V like that. Okay. The y2 in your problem is now this zero on the right. Okay, so because I've got digital ink here, I can color code it. I mean, if you had colored pencils or different colored pen or pencil, it would be good to do that. That's here at 0. That's y2 equals 0. Is that okay?
Yeah.
So what this is saying in words is where is y1 below y2? That's what the less than means. Where is it below I2? Now it says to shade, highlight where the y values satisfy the inequality. I'm not sure how you're supposed to do that if you don't have a highlighter, but it's these y values here.
Right.
Okay. And that's how you do this graphically, which is it's kind of not right, but this we'll just go with it for now. Maybe we should have solved it by hand first. I'm not sure. Any questions on that one, what I've done thus far?
No, I understand this.
Okay. Now that's kind of part B. To do part C, you actually do have to solve the absolute value equation, which is maybe what we should have done from the beginning. Like you have to write x plus 8, absolute value minus 16 less than 0. And you have to solve this using the algebraic methods that we've talked about. Your goal here is to isolate the x plus 8. So you're gonna move that minus 16 over.
Right.
Or by adding it. So now this is the between case. And I don't know if we've talked about this or not. The between case is when you write x plus 8 less than 16. And then over here on the left, you bring down the 16 and make it negative like that. Now, the reason it's between is because it's less than or equal to.
So you're putting it in on the other side, but then a negative?
Yes. And it sounds like that wasn't made clear in class. But
No.
okay. I don't know how you're supposed to know that. All right. And then you solve this, treating it kind of like what would you do to get x by itself, just like you would any other equation. Subtract 8 from both sides. Except there's 3 places to subtract 8 from. So negative 24 less than x less than 8. So we can do a few more of these like this. If we go back to the graph, though, there's some important stuff on the graph with these values right here. So this negative 24 is right there. That's negative 24 comma 0. This point right here is 8 comma 0. Is that okay?
Yeah. I'm
All
good
right.
with that.
All right. So that's sort of so we're kind of up to where we can do the answer to C. That C, this is C, but in interval notation, kind of. These aren't really. Let me not see it that way. So set builder. Let's do set builder first. Set builder is x such that, so this vertical bar, x is an element of the real numbers, comma, and then you put that inequality in the curly braces.
Mhm.
So that's set builder notation. Interval notation is based on what kind of symbols you have here. So the less thans go with, and greater thans, they go with parentheses. The less than or equal to, the greater than or equal to, they go with brackets. Okay, so this one is negative 24 parenthesis, and that's because it's a less than, comma 8, close parenthesis.
I got that.
All right, so that is part C. So what, so I'm sorry, we did this, I guess I did this really out of order. This is part A. The whole solving it is part A.
Okay.
And then we did the graph first. I'll do that in order next time. Part D is to check the answer. So it's, in this case, it's like to check x equals -1. A couple of ways to do this. You can decide whether it's in your interval or not. Okay. In this case, it is. -1 is between -24 and 8. Okay. The other way is to go back to the original and decide if this is true or not. So put -1 in for x and then reduce this. What way do you think you will do, or what's been like, what
I think the
makes the most sense?
reducing way is probably what I'll end up doing.
Like this down here on the
Yeah.
bottom? Okay, so tell me whether this is true or false or not.
True.
This is true.
Yep.
Yep. Okay, let's go to number. Let's go to number 6 because it's the most like the one we just did. We'll do that one next.
All right.
Let's not actually do this in the order that is given here. So part A is to solve the absolute value inequality.
Got it.
And this means there's no graphing. You just manipulate the equations. You move things around. Like imagine this was 2x - 4 less than 0. What is the first step to solve for x?
Let me write this down. Add 4 to the other side.
Yes, so you add 4 to both sides, and then you have 2x less than 4. Then you would divide by 2. So it's the same thing on the left here. Same thing on the left. You're going to add 4 to both sides. 2 absolute value x - 1 less than 4, and then divide by 2.
Right.
Okay, so this becomes absolute value x - 1 less than 2, like that.
Yep.
All right. Now, this is where, because it's less than, it's a between.
Okay.
Okay, so you write exactly what you have without the absolute value, but then you bring the number down and you negate it.
Got it.
All right, so then to solve for x, you have to undo this -1, add 1 to both sides. That's -1 less than x less than 3.
Got it.
All right, so when you graph this on a number line, I do think that's worth doing here. It helps to answer some of the other stuff. It's a filled in, I'm sorry, it's an open bubble, and it's everything between there. All right, so if we go to set builder, so I know we're jumping to part C, but C really does follow from A. Set
Okay.
builder notation is curly brace. You have to write this x such that x is an element of the real numbers. This is always in there. Always, this first part is always in there.
Yep.
And then you use that inequality, -1 less than x less than 3, close curly brace. Is that okay?
Yep.
Interval notation, a little more work to do. It's just though the numbers that you have from the interval, but with a parentheses or brackets, depending on what it is.
Got it.
All right, now part B is kind of kind of odd. Again, like this is not really correct, but I know I can't fix that. It's just, this is really odd, but it is common with this class. They want you to treat y1 as the left side, 2 absolute value x minus 1 minus 4, and y2 as the right hand side, which is 0. All right, so your standard form of a absolute value I'm writing down. The reason I'm writing it down is so that you can see that the vertex is h comma k. You have to be able to find the vertex in this problem for your graph. So what is the vertex for yours? What's h and what's k?
-1, -4.
So I agree with the -4. H
Oh,
though
1.
is just 1. It's typically opposite of what you
Yeah.
think. Now, the value of a tells you whether this opens up or down. Does this one open up or down?
Up.
It opens up. So on that awful graph they give you, I mean, you have to roughly identify that point, and this is where I'm not sure like how accurate you need to be, but you want to show that it does open up like this. Y2 is the 0. So it's y equals 0. And because it's less than, because of this less than here, we're asking where is y1 below y2? And so I've got a highlighter here. So it's everything that's where the black is below the red. Black's below the red.
Got it.
Now, in terms of those actual x values, we do know them from part C. We know it's -1 and 3. This is -1 and this is 3.
Got it.
And that's it. That's it for part B. To do part D, we actually probably should have done that. But you said no, you'd like to do it from the original. So it's 2 absolute value x minus 1 minus 4 less than 0. You're putting 11 in for x.
Mhm.
So I want you to put 11 in for x there and let me know your result on the left side, please.
X minus 1 is less than 2.
No, you've got to put that 11 in for x.
Oh. Wait, am I still solving this as an inequality or
No, you're
getting one straight number?
you're putting 11 in for x and simplifying this on the left. Like 11 minus 1, take the absolute value, multiply by 2, and then subtract 4. Two times the absolute value, 11 minus 1
Yeah.
minus 4.
I got it. All
Yeah.
right.
And then it's a question. It's like, is that less than 0?
Yes, that is it. That is less than 0.
Tell me what you got here. What is 11 minus 1?
10.
10. So it's 2 times the absolute value of 10 minus 4.
4.
The absolute value of 10 is 10. So that's 2 times 10. Right? Order of operations here. 2 times 10 is 20. 20 minus 4 is.
I
is
had
16.
a negative in that absolute value because I thought it switches, but my bad. I wouldn't. I had everything else. I would have got it if I didn't switch it.
Okay, so we're gonna do a few more like this. I'm seeing kind of a pattern here, and I know this. There's like 4 distinct things you're doing here, which is making this even more difficult. Okay, let me know when you get all this down. We'll do another problem like this.
Yeah, I got it all down.
Great. Okay. Why is this done this way? Okay. So here we go. Let's go. Let's say it's a 3 absolute value x minus 2 plus 6. Actually, yours are always with 0, so we'll do that. You change this number to a 4 minus 48 less than or equal to 0. Okay. All right, so let's just focus on solving this inequality. Okay, we're just going to solve it. We're not going to graph in 2 variables. Tell me the first step to solving this inequality. Here, please.
48.
Add 48 to both sides. Good. Very good. So we have 3 absolute value x minus 4 less than or equal to 48. What's next?
Divide by 3.
Divide by 3. Good. Absolute value x minus 4 less than or equal to 16. This is the between case. So tell me what to write to the right or to the left or both.
On the right, write less than or equal to 16.
Okay.
And on the left, write minus 16 less than or equal to. Yep.
Good. Okay, go ahead and solve this inequality from here, please.
Wait, I would just add 4 right here, right?
Yes.
All right, cool. Negative 12 less than or equal to x less than or equal to 20.
Okay. So this means that the solution is all the numbers from negative 12 to 20. And it includes negative 12 and it includes 20. And it's everything in between.
Yeah.
Okay. Does that like, are you believing that looks okay to you?
Yeah, I got that.
Great. So now if I asked you to test or try x equals 1, you should be able to look at this and say, I know it's a solution because 1 is between minus 12 and 20.
20.
Okay, but it's okay that you've not wanting to do that, but let's just go back to the original and let's verify that. Okay, I'm telling you it's true, but I want you to try that. That's not right. Wow, that's not right either. Trying to grab this. There we go. Copy and paste. I want you to put 1 into this inequality and tell me the result of the left side, please.
Okay. If I have a -3 in the absolute value, what do I do? Do I put it into a positive?
Yes, a good question. So the absolute value of 3 is 3. The absolute value of -3 is also 3.
Okay.
The absolute value of 5 is 5. The absolute value of -5 is 5. Do you see a pattern here on the right-hand side?
I see. Yeah.
Always returns a positive.
All right. So this statement is false. 39 is less than or equal to 0.
Okay, so I think you've got a sign error here. So you were asking all the right questions. 1 minus 4, absolute value. 1 minus 4 is -3. Absolute value of -3 is 3. So this is 3 times 3 minus 48. 3 times 3 is 9. 9 minus 48 is -39.
Oh shoot, yeah.
And is that less than or equal to 0? Yes.
Yeah.
And so the reason I was showing you this inequality graph on a number line here above and tell you that x does work is because your answer better be consistent with that. And this one, this is consistent that 39 is -39 is less than or equal to 0, but 39 is not less than or equal to 0. So that's where you almost have a built-in check there to decide if it's right or wrong.
Yeah.
Okay, let's try another one here. Let's go 5, absolute value 2x less than 40. I want you to try solving this one on your own, just the absolute value part of this. And please ask some questions if you're not sure about something along the way.
X is less than 20 over 12.
Tell me the first thing that you did here.
Distributed 5.
You can never multiply in. Never.
Oh shoot.
Okay, so this is good practice because we learned you cannot do that. Your goal here is to isolate the absolute value. Okay, which means you're going to divide both sides by 5.
Okay. Right.
Now that the absolute value is isolated, okay, you have to break this up into a between situation. So the 2x goes in the middle. Tell me what goes on the left and what goes on the right.
On the right is less than 8. On the left is -8 less than.
Good. Now you're almost there. You've got to get x by itself though. So how do you do that? How do you undo?
Divide by 2x.
Just divide by 2.
Divide by 2, yeah.
Okay, so -4 less than x less than 4. So we make a number line here. There's -4, there's 4. Open circle because of the less than or the greater than, those become open circles. The other ones become filled in. It's all the numbers in between. Okay. Is -5 a solution? Basically,
No.
I'm asking is no, it is not. So we know that this is false. Okay. So we're going to go back to the original. The original was 5, absolute value 2x less than 40. Okay. So because -5 is not a solution, when you put -5 in here for x, it better not work. This better not give you something that is true. If it does, you should look at your, multiplication sign error, stuff like that. What I'd like you to do here is put -5 in for x, and you always evaluate inside the absolute value first, then takes the absolute value, then multiply by 5.
Okay, so put in -5 for x.
Yep.
Okay.
Let me know what you come up with on the left there.
Okay, I have a final like solution, but I'm not sure if there's one more step I need to do.
Okay, so did you write something like this? 5 absolute value 2 times -5.
Yeah,
What is 2 times -5?
-10.
So it's the absolute value of -10. What is the absolute value of -10?
10.
And then you multiply by 5. So you substitute in first. Then you do the part inside the absolute value. Like there's actually parentheses. They're never written, but there's actually parentheses inside the absolute value. Like you're supposed to do that first, which you did. Then you take the absolute value of it. So when you take the absolute value, it always returns positive. What is 5 times 10?
50.
50 is 50 less than 40.
No,
This
that's
is
why.
false. And
Yeah,
that's what we wanted. We said -5 is not a solution. So this better not be a true statement.
yeah.
Okay, try to verbalize what you think you're struggling with, because maybe there's many areas, maybe there's only one. What do you think you're
Oh,
struggling?
I just thought I had to get 50 over the other side, but I don't. I can just leave it like that.
It's weird. The check is like normally when you check something, you look for equality.
Yeah,
Okay, but like there are times where the check is you want something to be larger or something to be smaller. And we could think of examples if you want, but I think the uncomfortable nature of this is that you're just checking whether something is less than or greater than, not equal to, which is what you've been doing the entire year.
yeah.
Okay, let's try another one here. Let's go absolute value 2x minus 1. Absolute value. Let's put a 3 here and minus, gotta be careful here with these numbers, 15 less than or equal to 0. Do you want to try solving this one on your own?
Yeah.
Okay.
X is greater than or less than 2.
Okay, help me out here, because it should be something like there should be this number, and then there should be a number on the left, and then it ends up being X in the middle and a number on the right.
Oh, it's one of the, I was able to get a fully,
Okay, so tell me what you did first. Give me your what's the first thing that you did?
I did plus 15.
Good. Okay, so that's 3 absolute value 2x minus 1 less than or equal to 15. What is the next step?
Then I divided by 3.
Okay, I'm hearing all the right things. This is good.
Yep.
Okay, now this is where you have to break it apart. So every single problem, when we've isolated the absolute value, that's when you split it up into the number and then the negative of the number.
Yeah.
Okay, did you do that? It's okay if you didn't, I'm just asking.
No.
Okay.
I did a +1.
All right, so you cannot like I don't want to say this. You have to deal with the absolute value. Like, see how there's no absolute value in this next line?
Yeah.
When you have a less than or equal to or less than, it's the between. You always write as a between. Maybe your teacher is saying and. I think between's better, but you do add 1. You do add 1 because you are solving for X. Okay. And the good news here is that part of your answer was correct.
Right. part of it. That's good.
Okay, so you do divide everything by 2. Okay, so now -2 less than or equal to x less than or equal to 3, or x is between -2 and 3.
So that's my final part
Yes,
for my
yes,
statement.
yes, yes.
Okay.
So now is -1 a solution?
Yeah.
Absolutely. It is. It is. Okay. All right. So here's again, just like we've been doing before, since this is a solution, if you need to copy something down, let me know.
No,
Just
I'm good.
okay. Since this is a solution, when you put -1 in for x, this is going to work out, meaning you're going to get something on the left that is less than or equal to 0. So I'd like you to do that. I'd like you to evaluate this absolute value for -1, like put -1 for x, do the multiplication, subtract,
Put
then take
-1 in for x or any number.
-1,
Okay.
-1.
Wait, should the number in the middle be -2 times -1?
It's 2 times -1, so
And
that becomes -2.
then -15 on the sides or what?
Yeah, you bring them down, but you don't evaluate until you like keep focus. This is like a simplification problem where you
Right.
just keep going one step at a time. Like, what is -2 minus 1? Do that. These are
-2 -1
yes,
-3.
-3. And these are like, I'm asking you these questions. If you have questions, it's all good to ask because this is so important. Any little sidestep here could be catastrophic in these
I got
problems.
you.
So absolute value of -3 is 3. And then from all the way up here is -6 less than or equal to 0.
That's true.
Is that true? Yes. And is that what we wanted?
Yeah.
Yes. Yes. Okay. Now let's look at this interval one more time. Is 4 a solution? Is 4 a solution in this interval?
No.
No. So here's what we're gonna do one more time. I'm gonna have you evaluate it. It's usually easier to do with the positive numbers. We know that 4 does not work. Okay, so when you evaluate for 4 here, you will get a non-true statement. I'd like you to do that. I'd like you to put that 4 in for x and simplify, please.
Okay. Wait, do I have to move a negative, or
No,
should I move a negative 15 onto the left
no,
side?
no, you're just working on the left. You're just working on the left.
So add 15.
You're just doing this part on the left. You're just putting 4 in for X.
Oh, all right, I got that.
So I'm asking you to simplify this all the way through.
Six.
Okay. That is true. So is 6 less than or equal to 0?
That's true.
6 is less than or equal to 0. 6 is less than 0.
Wait, no.
This is false.
Yeah, that's false.
And that's what we said. We said this is going to be false. Okay. You're a sports guy, right?
Yeah.
So try to think about this in terms of how instant replay is used. Okay.
Okay.
Let's look at they call on the field is a touchdown. Okay.
Okay.
Then they go to the replay and they also find that it's a touchdown. Okay.
So it confirms it.
It confirms it. Here's what that was in our scenario up here. We said that -1 was a solution, right?
Yeah.
That's a touchdown. Okay. Then I made you put it in here and you said, yep, we just confirmed it. It's a touchdown.
Got it. I see.
So we're trying to show the two ways that it is a touchdown, that it is true.
Right.
Okay. So they can't be inconsistent. Now, I know there's going to be an issue with replay, but there's also the situations in instant replay where, I don't know, let's say, what's another scenario? A fumble.
Oh, and they go back and confirm it.
Yeah, like you got to think of something negative here, like
Yeah.
it's something that didn't so. But let me be so yeah. So try to think of it as we're just trying to confirm what we already know to be true. We're just showing it a couple of different ways. So let's figure out the inequalities here for a moment. Let's just say I asked you to evaluate absolute value x -3 + 8 for x equals -6. Okay, so all I want you to do, Mateo, is just put -6 in for x, subtract 3, take the absolute value, and then add 8.
Okay. $17.
Okay, so absolute value of -9 is 9 + 8 + 8 + 8. So now let me add this in: greater than or equal to 0, or greater than equal to 0, greater than or equal to 0, greater than or equal to 0. Is this true?
Yes.
Yes, it is. Okay. So I think you were getting caught up on this inequality stuff, but your focus, and this is more on me because I probably should have just had you focus on it, is just on this left side. You're just working out on the left.
Yeah.
Okay.
All right.
All right, so let's try, we got a little bit more time here. Let's say you've done all the work and you've got an absolute value of 3x less than 18, like this. What is the next step? What do you do from here to kind of break this apart?
Divide by 3x.
You have to get rid of the absolute value first. So you split it up here.
Oh, yeah. Okay.
Okay, so that it comes down exactly the same, and then you move this over. How do you undo the multiplication by 3?
Division by 3.
Divide everything by 3.
Yeah.
-6 less than or equal to x less than or equal to 6. Okay, so my question to you is -4 true?
Yeah,
It is, okay, -4 works. We know this is good. Okay, we think it's a touchdown. Okay. We're now going to go back to the original and verify that. We're going to replay. Is this true? So I want you to put -4 in for x. Don't even focus on that 18. Just ignore it. Just focus on the part on the left. Absolute value 3 times -4. Tell me what that is. Just that part.
tell you if it's good.
Just give me the number on the left. Just
-12.
the absolute value of -12,
12.
which is 12. Now bring this down. Is this true? Is 12 less than or equal to 18?
This is good.
This is true, and it's supposed to be. It's supposed to be consistent.
Yeah.
Okay. All right. So we didn't get through everything on this sheet, but we did all the less thans. We did all the
Yeah.
less thans, less than or equal to. Next time we'll work on the greater than, the greater than or equal to. Should go a little faster, and then you've got kind of these quadratics, inequalities that we can look at. But we do have to stop here for tonight. So I'm gonna go and stop the recording. I don't know why I can't do that. There it is.